let you talk. So Dr. Rebecca Fiebrink, she graduated from Princeton University with a PhD in 2010. Since then, she has held academic positions at Goldsmiths University and Princeton University, whilst collaborating with such companies as Microsoft, Smule, and Imagine Research. More recently, she joined University of the Arts London as a reader with the Creative Computing Institute. And whilst she might be best known in the creative machine learning community as the creator of the Wekinator, a fantastic software for using interactive machine learning models as multimodal customizable controllers that was used since its creation by more than 20,000 artists and programmers alike, the range of topics she has worked on during her now 10 years long career is actually much wider than just this, as I'm sure this talk will show. I personally got to know Dr. Fiebrink's work at a keynote she gave at the ISMIR conference in Paris in 2018, which was sort of a revelatory moment for me for how machine learning could be made actually fun and usable for creative applications. So it is both a pleasure and an honor to now have an occasion to host her for this Etincelle seminar.
Thank you so much. It's really a pleasure to be here. So today I'm going to be talking about the way that I think about machine learning now, having worked with it in creative contexts for about 13 years. And my goal here is no matter what domain you're coming from, if you're using machine learning or doing research with machine learning, or just one of the many people whose work is going to be impacted by machine learning in some way, I want to encourage you to think about it more broadly and to think about it outside the sort of tropes that come up both in the digital arts community and in the media. So I think for most people, if they're familiar with the really explosion of machine learning in art and creative practice in the last 5 years or so, they're likely thinking about GANs. They're thinking about work like this portrait of Edmund Bellamy, which sold for something like $400,000 at a Christie's auction in 2018. More recently, of course, there's been really exciting breakthroughs coming from companies like OpenAI, not only with language models like GPT-3 that can write new text, but also applications in music and visual content creation. So you may have seen this is an example from OpenAI's Jukebox project, where they made a hot tub Christmas song sung by a very convincing AI, Frank Sinatra. And I find these projects really exciting in many ways. I think the fidelity with which we're able to create high quality content is certainly far beyond what I thought we'd be capable of doing, 5 or 10 years ago. However, in a lot of these projects, there's an interaction model which is, well, missing, right? If you think about what these kinds of tools on the surface offer to human creators, it's sort of like, the old Microsoft Clippy, as if he pops up and says, it looks like you're trying to create some art or some music. Would you like me to do it for you? And there's not a lot of really obvious, rich interaction possibility connecting these algorithms to human creators. And so I think, we can dig into this, and there are more possibilities than often meets the eye, but there's also a broader range of ways that I think machine learning can and does impact on human creative practice. So that's what I want to talk to you about today. My research for the last 13 years or so now has been around questions like how can people, existing creators, use machine learning within their own creative practices? Everybody from students to professionals to children and the broader public. I'm also interested in how machine learning can expand people's own creative capabilities. And of course, if you think about what machine learning really is, it's really just a set of tools for finding patterns in data, making predictions from those patterns, and maybe generating new data that follows some kind of pattern. And so we can ask when and why is it creatively useful to do these things? But also, how might people's interactions with these algorithms be structured? How can we enable creators to use machine learning effectively? So I'll talk about this today, drawing on my own work, both Wekinator tool, which I'll start with and give you a demo of that, but also the work I've done since then, and some of the creative practice beyond my own work and my students that I think fits into the kind of new vision, new understanding that I've developed for machine learning. So how can people benefit from finding patterns, making predictions, and generating new data? I think this is a really exciting starting point. If we start looking around at, what this data might be that's of use to creators, it's far beyond the large sets of images or large collections of MIDI or audio files of music. Potential sources of data are really everywhere, right? It could be data that we generate intentionally by, say, moving our body in front of sensors like leap motion, or moving in front of a camera, or singing or playing an instrument into a microphone. It could be data that's collected passively as we interact with our smartphones or interact with Photoshop or digital audio workstations. It could be data that's mined from social media. It could be data that audiences at installations or performances also contribute to, right? There's lots and lots of data that could be great to integrate into creative work, or that could be integrated into tools that support creative artists. Now, increasingly, with the great sensors we have, with the great APIs that a lot of services are providing, getting data is pretty easy. However, even for expert programmers, of course, interpreting and using data can be really hard, right? Think about trying to make sense of data from a webcam or a sensor, or the trace of interactions with a tool like Photoshop, and trying to make sense of what somebody is doing, or predict what somebody might do next without using machine learning, right? This is a very hard problem, and of course, machine learning can help us out in a lot of ways. Now, when I started working in this area in about 2008, I was working with musicians, mainly experimental musicians, doing work with digital interfaces. And a lot of what they wanted to do, and what a lot of art students and game designers and other folks I work with right now, a lot of what people want to do with data is applying labels, making decisions, making predictions. So, for instance, we can think about building a new gesturally controlled musical instrument where somebody is moving. Those motions are captured with sensors, and based on how somebody is moving, the computer makes a decision about what kind of sound to play as a result. Or we could imagine making, say, a multimedia performance system in which a person is playing music into a microphone, and based on the properties of that music, somehow the lighting or the live visuals change. In a totally different domain, you could imagine actions of a gamer, motions that they use with their body, words that they say, sounds that happen in the environment. You could imagine these influencing some aspect of gameplay or avatar behavior. So when I started working in this area, there really wasn't a good set of tools to allow creators to build these kinds of machine learning systems. When I say these kinds of systems, if you know anything about machine learning, you'll recognize this as a really nice fit for supervised learning algorithms. So I developed a tool called Wekinator, starting in 2008. It's still around. And it originally was a tool to enable people to just use supervised learning more effectively, even if they weren't expert programmers and even if they didn't know much about machine learning previously. Um, there were some differences that I learned that had to really be embedded in this kind of tool to make it useful and usable by people. So whereas initially I said, well, the big difference between Wekinator and tools like MATLAB or the original Weka toolkit that was around at that point, I said, the difference is mainly you need a nice user interface where people don't have to code, and you need it to work in real time. And if you can do that, you can build a model that does prediction. We can send it sensor data, and then that model will give us control signals that we can use to control sound or animation or games and so on. And to an extent, that's correct. But actually, what happened was that I learned that there are a bunch of different design possibilities and design constraints to work with, and I'll tell you about those in a moment. But of course, there were also really interesting creative consequences that arose once I was able to build this kind of system that was useful for people. And I call Wekinator a meta instrument because it was originally a tool for people to build new digital musical instruments. But actually, once people started using it, the kind of interactions that they began to develop with it felt very instrumental, playful, performative, expressive. These are words that people use to describe their experiences building things with machine learning. So that's a description that still, I think, is appropriate for me, even when people are using Wekinator to build, say, art installations or games. It is an expressive piece of software in which machine learning is a way for you to be creatively engaged. All right, so as I mentioned, merely taking off the shelf algorithms and putting a nice, friendly, real-time user interface on top of them didn't end up being enough for what people really wanted to be doing. So for instance, let's imagine that you're building a new musical instrument in which you move your hand and the computer responds by changing sound. The first challenge that you confront is actually there probably isn't an existing ground truth data set that you can just download from Kaggle or something and use that to train your algorithm on, right? You are probably the only person who has in mind this particular relationship between hand movements and sound that you want to embed in your instrument. So the first thing you have to do is actually create or curate that data set. So that's the first thing that Wekinator allows you to do in the software is really focus on making a good data set. Second of all, let's say you build a model from those examples of hand gestures and sounds. This model is going to be capable of looking at new hand gestures and producing new sounds or control that's sent to a synthesizer that produces those sounds. What does it mean if you test this model on a holdout test set and you get 90% accuracy, or you use a cross-validation approach and you get 93% accuracy? Like, what does that even mean? Does that mean that this model is better than something with less accuracy? Does it mean that it's good enough to use in a performance? Not necessarily. It actually is not very informative to take existing evaluation metrics designed for totally different applications of machine learning and use that to say something useful about a model that you built for making a new musical instrument. Much more useful is to take this model and actually play with it in real time, right? Move around, see what happens, see mistakes are made, see whether you like the thing that you've built, right? And if it makes mistakes, the third thing that ends up being very appropriate in this context, but which is not at all standard in most machine learning domains, is that it's sensible for you to go and edit the training data, right? So if you notice that it makes a mistake for some kind of action, often the best thing you can do is go back and add more examples of that action paired with the correct sound that you want, and then retrain your algorithm on that new augmented set of examples. Right, so this in the human-computer interaction field is what we would generally call an interactive machine learning approach, where there's an iterative process of model building where we're being kind of messy. We're doing things that might break the rules in a traditional machine learning context, but it actually ends up being very effective to allow people to build new instruments and other interactions very quickly. All right, so if I were there in person, I would do some really fun demos for you live. That doesn't work so well over Teams or Zoom, so I've got some pre-recorded videos for you, and these are going to illustrate the kind of interaction that I just described. All right, in this demo, I'm going to build a very simple gesture-controlled drum machine using Wekinator, as my input device to capture information about gesture, I'm going to use my webcam. And I've got a little program here, which I like to call the world's worst computer vision feature extractor. What I'm doing is just taking those pixels coming in from the webcam and downsampling that to a 10 by 10 grid of color values. And this gives me 100 numbers, and these numbers are going to change as I move in front of the camera, as you see. But even if you're an amazing programmer, I would guess that you would not want the job of writing the program that looks at these 100 values and says something useful about what I am doing in front of the camera. So instead, we're going to use machine learning to make sense of these 100 values and make pretty accurate predictions about what kinds of gestures or motions I'm doing. All right, so I'm going to have Wekinator here listen to 100 values from this camera program. And I'm going to build a classifier, which is going to again, predict what type of action am I doing at the moment. And we're not going to load a training set from somewhere else. We're actually going to build this training set right from scratch in the demo. And I want to, not just have Wekinator output a number. I want to have this control a sound and make this a little bit fun, right? We're going to control a drum machine, like I said. So I'm going to run a very simple drum machine program written in Chuck. And when I send this drum machine different numbers, we're going to hear different sounds, just like this. All right, so let's start out. Let's give it some training examples. And I'm going to say that when I am right here in front of the camera, I want to hear this simple sound. So I've got 17 snapshots of me here paired with this sound. And next I'm going to tell it that when I'm not in front of the camera, turn that down so you can hear. When I'm not in front of the camera, when I'm out of frame, I want to play a different sound, specifically this one. Let's go. Okay, now I've trained, I've built my model. Let's run this model and see what happens. Okay, it's pretty good. It's definitely changing between the two sounds, more or less the way I'd like it to. However, it's being a little bit too eager to change to that second sound, even when I'm not totally out of frame yet. So I'm going to give it some more training examples to try to fix that error and say that when I'm right here, actually, I still want to hear the first sound. And now I'll retrain, I'll rebuild that model, and we'll see if it works any better. And in fact, that's pretty good. I can keep moving around and see if I can make it make other mistakes, like right here. I can, oops, forget I did that. Let's give this as sound 1 and say that I want sound 1 over here. And I can retrain and keep running and see that, yes, it's doing what I'd like. And once I'm happy with that, maybe I want to make it more complicated. I could give it another sound with, say, my hand in front of the camera, like this. Okay, there we go. That is a pretty easy way of using Wekinator to make a classifier where I'm controlling a few different sounds based on simple movements of my body. All right, so that demo I just showed you was pretty fun. You can imagine that for an audience, watching somebody move on the stage is probably more interesting than watching them just change sound by clicking a mouse button. And in the hands of a good choreographer, you can imagine something that becomes really visually compelling as well as sonically interesting. But when professional composers have used Wekinator, they're using it in a slightly different way, often to exploit the fact that you can use machine learning to build very different types of instruments. The sounds that you heard in the previous instrument were the same sounds that I could easily make by just pressing a few buttons to switch between different sound options. But sound becomes a lot more fun to many electronic composers when you can explore a really big space of sounds, when you've got a large palette to draw from and you can come up with ways of playing sound that are much more nuanced, much more complex, more exciting than just switching between a few different presets. So in this demo, I'm going to show you how you can use Wekinator with regression to do exactly that. And the instrument we're going to play is going to control a sound synthesis algorithm called Blotar. And Blotar is fun because it has a lot of different sounds that it's capable of making. So here's just a few of the Blotar sounds. Okay, and for each of these sounds, I'm getting that sound by giving Blotar a different set of control parameters. Specifically, I'm changing 9 of its control parameters. So you can think of each of those sounds as a point in a 9-dimensional space. And I'm going to build a Blotar instrument where I control these sounds using this. This is a game track controller from an old PlayStation game called Real World Golf, but we're just going to use it as essentially a 6-axis joystick. I get X, Y, and length of each of these 2 strings that I pull out of the base here. And so I'm going to tell Wekinator I want to take these 6 input values and use them to control those 9 blowtar parameters. And I'm going to use regression so I get smooth changes. And of course, this is, again, something that would be really hard to do even for someone who's an expert programmer, because not only are you trying to find good positions in this 9-dimensional space, but you're trying to come up with a mapping function that says how the motions that somebody's doing here move you through that space in a way that's not only musically interesting, but maybe gesturally comfortable, where the gestural mapping might be easy to learn or easy to execute certain gestures that give you sonic gestures, and so on. So that's very hard to think about as a programmer. It's a complex function to write, but here we can do it pretty easily with machine learning. So I'm going to start out by finding a sound that I want to put in the blowtar. And maybe I want that sound, and I'm just going to put it over here pretty comfortably. Record some examples, and maybe another sound higher in pitch, say over here. You can record some examples here, and just training from these, you understand what's going to start happening. Okay, so I've got smooth change, and it's learned that lower pitch is over here, higher pitch is over here. That's fine, not too interesting yet. Let's start to add more sounds in and see what happens. Put this sound over here. Should mention this is taking a little bit longer than usual to train because I'm running my video capture software at the same time. Okay, so hopefully you saw some interesting stuff happening there. Not only was it giving me access roughly to the sounds that I put in the training set, and still having this behavior that when my hand was kind of back here, I was getting a low to high pitch relationship, but it was also giving me all sorts of other sounds as I moved between these very, very different timbres, which I'd put in different parts of my gesture space. I was getting sounds that I didn't put in the training set that I have never heard before, even though I do this demo quite frequently. And this means that I can start gesturally exploring the space of this synthesis algorithm. And of course, I can use machine learning to refine this instrument or this mapping that I've created. If I like a sound somewhere, I say, oh, that's a really cool sound and I like it where it is. I can add more training examples of that pair to reinforce that behavior. Or if I don't like a sound somewhere, I say, oh, that's silly, that's silent, or that's just really stupid sounding. I can put a different sound in that part of the gesture space and retrain it, and I'll get a different instrument. And I can keep refining my instrument in this way until I'm happy with it. Then I can save the whole thing and run it, the models as they are during performance. Or perhaps I could even write a piece, and I've done this a few times in the past, where a performer retrains the instrument on stage, and the evolving relationship between sound and gestures is part of a piece. But most composers don't do that. Most composers spend a fair amount of time refining the instrument until it's something that they're happy with, and then they move on and do other aspects of the work. All right, so those are the demos. I now want to finish up this talk. The last part of my talk is a sort of high-level view, taking Wekinator as a departure point to talk to you about what I've learned about how machine learning can support and expand people's creative practices. Now, Wekinator's been around for almost 13 years now. The most recent version has about 40,000 downloads. So it is used pretty widely, both in computer music and in interactive art. People have made dance pieces. I'll show you some examples of things people have made. And, I came into this work primarily as a computer scientist, right? My machine learning training was all as a computer scientist, and working with creators, both professionals and the thousands of students I've taught in courses and online classes and workshops. This work has really changed the way that I think about what machine learning is good for, why we might want to use it, and the real opportunities and challenges that arise when we try to make machine learning based tools for human creators to use. All right, so I've got, I think, about 5 or 6 high-level points that draw on my own research in this space and a few other creative projects that I really like from other people. To really talk about, what might creative human machine learning interactions look like, and what consequences do these interactions have for creative practice as well as for tool design. So I'm not just talking about the shallow, fast creative machine learning that you see in Wekinator, but I think there's implications here for deep learning, for generative machine learning as well. All right. So the first finding I want to share is most closely related to the initial work that I did with Wekinator, and it's maybe the most obvious, least dramatic finding, but it's important for a lot of creators in a lot of fields, which is that yes, machine learning can help us unlock the interactive potential of sensors and of other data. Lots of people want to work with sensors. They want to work with the body. They want to work with social media data and other data sources. And as I mentioned at the beginning, this is just hard to do without machine learning. So we can build tools like Wekinator and variations of that really do help people in a lot of domains make cool stuff. So I've got some cool examples to show you of a few different creative projects. This first one, this is one of the first pieces that was made by a composer using Wekinator. This is From the Waters by Anne Heggie. And she's using as an input device the same old PlayStation controller that I showed you in the second demo. And she's built a system where people move almost like a yoga sun salutation. And I think it's just a really beautiful piece. And as you watch it, I think it should be obvious that this would be challenging to create without machine learning and much easier to create if you're building something from examples. All right. The second example I want to show you is another composer who's built a musical instrument. This is Letitia Sanami. Her instrument, Spring Spire, you see here, she's been using machine learning to build this for something like 8 or 9 years now. So this is a very highly developed instrument. This video is a few years old at this point, but the form factor here is quite interesting. So what she has is a metal frame with 3 springs attached to it. And at the end of each spring is an audio pickup. And you're not actually hearing the sound of the springs themselves. Rather, what Letitia is doing is looking at the frequency content of each spring using a set of bandpass filters, and using that frequency content from the springs as inputs, as control sensors, basically, into a machine learning system where it's analyzed and then used to make decisions about how to control a set of digital synthesis algorithms, right? So what she's made here is a very complicated physical sensing device that she can play with a variety of gestures using her hands. And there's something like 36 different dimensions of input here, and it would be absolutely impossible to build this kind of instrument using programming. You really do need machine learning to build this kind of thing. So here's a clip of Letitia. All right. I want to show you a few other examples of non-musical work that people have made. As I mentioned, it's been used by interaction artists, experimental artists. This is a really cool piece in which you wear a camera on your head. Camera is sending data to Wekinator in order to drive a classifier that classifies whether you are looking at a screen, whether there's a mobile phone or laptop or television in your field of view. And if a screen is detected, then these special glasses you wear turn opaque, so you can't look at screens while wearing this crazy piece. This is a really quick student project from a workshop, which I really like. This is using a leap motion hand sensor attached via Wekinator to an Arduino with some cardboard. And this is all it does. So this is Highbot. When you wave at Highbot waves back. So obviously something you could build without machine learning, but it would be a lot harder. It would take more time. Wekinator's been used all sorts of other projects. If you're interested, you can go on YouTube and Vimeo. It's been used in quite high profile performances, like Alex Murray Leslie from Chicks on Speed has used it to make foot and shoe controllers, performed at Ars Electronica. It's been used by startup companies, including Voclia, who makes a really cool sort of beatbox and singing driven audio synthesis program. And then it's been used in just fun stuff like digital puppets shows, or somebody made a Google Maps controller where you can hold up food from a particular country and Google Maps will take you to that country. All right, so now let's talk about the things that are surprising, the ways that my work and other work in this space has changed the way that I think about what machine learning is good for. First of all, I want to talk about the meaning of data. So if you've come to machine learning from a computer science or data science background, you're probably used to thinking about data as something that's, ground truth, right? Something that is collected from the world. You want to collect as much of it as you can to adequately represent the phenomena you're trying to model. And then this data becomes your way in to accurately modeling that phenomenon. That's fine for many domains, but in the kinds of projects that I've just been showing you, data isn't exactly serving that role. Data is instead a way for people to communicate their ideas and their intentions. And it's not about finding the best data set of, say, hand gestures and sounds. It's about saying, okay, what do I want this relationship to be in the instrument that I'm creating? And can I come up with a data set that communicates that clearly, that enables me to build a model that doesn't make mistakes, or at least makes mistakes in low risk or unproblematic ways, and the things that I really care about, it can do accurately. And this isn't just something that is inherent to Wekinator or to supervised learning. If you look at some of the really, I think, interesting artists doing work with generative machine learning tools and some of their writings about their work, you'll find the same kind of theme. People talking about their relationship with data as the starting point for machine learning and something that allows them to have a lot of creative input. So Anna Ridler, for instance, is an artist who did a piece in 2017 using Pix-to-Pix image translation. And she was training this algorithm in part on a set of drawings that she made by hand. And in this really fantastic blog post about that piece, she writes that the control that comes to me in this process really comes from what I do with the data set. So I think this has really important consequences when we think about how machine learning can be used in creative work and how we build interfaces for people doing creative work, right? Can we think about how to enable people to have more effective control over data, more effective creation or curation of data, enable people to reason about data and the impact of that on trained systems, and so on. So this has definitely influenced the work that I've done since Wekinator. Another interesting surprise that hit me when I was doing this work, beginning with Wekinator, was that actually machine learning can be a much faster tool for building systems than alternatives, especially programming. And of course, we don't always think about machine learning as fast because so many of the state-of-the-art deep learning algorithms right now might take hours or days or longer to train. However, if we're using very small data sets, like in the examples I showed you, or if we're doing other types of techniques like transfer learning, it can actually mean that we could build a new bespoke system in a matter of seconds or maybe minutes at most. And this means that it can be easier for somebody to prototype a new idea. It can also be easier for people to change, say, the training data in order to iteratively modify that idea. And of course, if you know anything about creative practice or you are a creative practitioner yourself, you may know that this process of rapid prototyping and exploration is really key to doing any kind of creative practice effectively. So when I was interviewing and observing people using Wekinator 10 years ago, one of the most surprising things for me was that um, they weren't spending less time building instruments or building interactive systems, but they actually felt often more satisfied with the time that they spent because they felt like it was more productive. Instead of debugging code and trying to search for software errors, or thinking about a new feature that they might want to add and saying, you know what, I just can't devote my time to that because it's going to take me 2 days to build it and I don't know if it's actually going to be any good. People were actually using machine learning, using this iterative process of changing the data to try out new ideas quickly, refine not only their design, but their ideas about what they wanted to build, and ultimately emerging with something that they were happier with. Now, there's another really interesting consequence of using machine learning on data rather than building things by code. And again, this isn't something that was ever in the minds of machine learning designers, but it turns out to be really effective in many creative contexts, which is that building something from data using machine learning can be just much better than building with math and code when you have a human creator who wants to communicate tacit knowledge or embodied practices to a computer. So if you think about many of the things that people do that we deeply enjoy, everything from painting to playing musical instruments to sports or dance, right? These are things that are often very hard for us to describe to other people in our native language, right? Think about trying to describe to somebody how you play a violin or ride a bicycle. It's very difficult, even if you've been doing that for decades. It becomes even more difficult if we're trying to express this through mathematics or essentially, mathematics wrapped in code, right? It's much easier if we can demonstrate the sorts of ways we want to move, the kinds of sounds we want to make, and so on, right? This is a more natural interface for us. And of course, using machine learning allows us to take advantage of this more effective communication medium. So this came out in my research when I started interviewing people about in the very early days, why are you using machine learning? And people saying things like, well, it allows me to really feel the music as I'm playing it and developing it. The fifth point I want to share with you is that designing with data rather than forcing people to build things only with code can enable more people to become creators. And I think this is an idea that's been explored more and more in a lot of different applications of machine learning recently, which is exciting. If you think about Neural Doodle or more recent NVIDIA demos where you can sketch something really rough and basic as a novice, and then it'll sort of turn that into something that looks like a work of art or a photograph. Or there are increasingly in both audio and visual tools, things like Isotope or Photoshop now, tools that allow you to do more effective, very complicated types of editing without necessarily doing all the details yourself. There's been a bunch of Google Doodles, including one that allowed you to put in notes and then it would fill in those notes as if it were a chorale written by Bach. Right? These are all really cool. However, I think it's worth noting we can go beyond that in thinking about how machine learning can make things more accessible. So all of these models or examples on screen use machine learning to make it easier for novices to conform to some standard, which is undoubtedly fun, but it's not the only thing we can do. So in my work, a lot of my projects have looked at how people can design with new data, data that they've created or curated, designing with data that for them allows them ways to personalize systems, to adapt systems more flexibly. And of course, one of the most exciting areas for this kind of work is in the realm of making new interfaces for people with disabilities. I have a recent project called Sound Control, in which we built a Wekinator-like interface with music teachers and music therapists so that they could work with kids with a really wide variety of disabilities. And initially, our goal was for them to be able to make new instruments for these kids, right? Somebody who might not be able to play a violin or a guitar could take something like a game controller or hold a colored toy in front of the camera and use object tracking to change the sound. This was a really fun project because, yes, actually, machine learning allowed the teachers and therapists to build new instruments for kids that allowed them to play music in new ways. But even more than that, I think even more exciting is that the kinds of things that they ended up building when they had access to this example-driven tool were far more diverse and far broader than that. So they built games, they built sort of technologies for collaborative jam sessions. Once they had the ability to say, you know, we could build whatever we want, it went far beyond what they would be able to achieve, even if they had an engineer sitting there taking their design specifications and doing their bidding. All right. The last point I want to share with you, again, something that I'm very excited about, is this potential for machine learning to open up new creative relationships between people and machines. And again, this comes back to the concept of meta instrument that is in the title of my talk that I've hinted at here and there. The creative practice with machine learning can involve not just an outcome that's creative, right? Something that allows you to perform on stage and feel creative, but actually a process that can feel more creative. All of the consequences I've talked about so far in this talk suggest ways that design itself can become more embodied and can become more playful, can become more satisfying. And I think this is important. I think existing generative machine learning tools in many ways also allow creative palettes to become richer. And one of my favorite examples of this is the Edges to Cats tool. If you haven't seen this, this uses a generative machine learning approach that allows you to sketch an outline of a cat. And once you hit this process button, it'll fill that in with whatever cat-like thing it can, right? And people, of course, have not been using this to make new pictures of cats largely, but they've been using this as a new component in a creative palette where you could draw an octopus or bread or Batman, and it'll make, cat octopus or cat bread, right? So there's all sorts of, I think, unexplored territory here where we allow people to take these new tools and do something else with them. It's not just about making the next Van Gogh or 18th century portrait. It's not just about making the next unheard Frank Sinatra tune. It can be about totally different things. I want to come back to another quote from Anna Ridler, whose blog post on the fall of the House of Usher I already mentioned earlier. And I think, fundamentally, many artists working with machine learning in their writing talk about how control, power, and agency can become complicated in really good ways. And again, I don't really see lots of examples of people talking about how the machine has its own agency and the machine is replacing the human doing creative work. I think there's much more interesting stuff at play. So Anna, in her blog post, says that this idea of control is misleading. It's impossible to predict what will come out. I can guess, but I cannot know. The errors and choices that are made when I'm drawing are amplified, and the GAN holds a mirror up to my own drawing and makes me realize things that I was not aware of, what I find the most important, what I always edit out. It is my work, but also not my work, recognizably me, but nothing I would have been able to do by myself. Watching it is a very odd sensation, like catching a glimpse of yourself in a mirror before you realize it is you. And I'm going to share one more artist quote from you. This is from Letitia Tsunami, who made the Spring Spire. And when she talks about why she uses machine learning, specifically Wekinator in her work, she says, in a way, you don't want the instrument to perform like a well-trained animal circus. You kind of want it to be a little wild, and you want to adapt to it somehow, like riding a bull. I think the machine learning allowed more of this fun of exploring instead of going, I have to have a result right away. This thing is going to do that, and leaving it at that. And again, I think here we're transcending both the sort of stereotypical understanding of machine learning as a human-like agency that can replace human activity. We're also challenging and moving beyond stereotypical understandings of control in non-machine learning interactions with computers, right? So if you look at the history of human-computer interaction, often it's a history of assuming that the human should be completely in control of what the computer does, and we just need efficient interfaces for the, maybe the genius human to get the computer to do exactly what they want. And I think artists, of course, using machine learning are finding that there's a lot more room for other types of fun here. All right, so in summary, I've talked about how machine learning can unlock the creative potential of sensors, enable creators to better communicate more effectively with computers, especially about tacit knowledge and embodied practices, can support rapid prototyping and exploration, enable more people to become creators, and especially allow easy personalization and flexibility. And of course, we can open up new creative relationships between humans and machines. I've got just a couple quick slides now to illustrate some of the questions I'm currently thinking about. I'd welcome discussion or questions about these at the end. So I'm looking at how we can make interactive machine learning tools well suited to other domains. Currently, I'm working on a project called Interact-ML, where we're building Wekinator-like tools for Unity and Unreal game engines. In the Mimic project, I'm working with some collaborators making machine learning tools that we hope are going to allow for playfulness, accessibility, exploration, and meaningful interaction with other types of machine learning algorithms, especially generative and deep algorithms. I've spent a lot of time thinking about how and what we should teach creative practitioners about machine learning. Unsurprisingly, I believe that creative machine learning users can benefit from knowing something about machine learning, but they benefit from different knowledge and skills taught in different ways compared to how we would teach computer scientists. And finally, of course, I think most people's, in our society, most people's experiences of machine learning is not one that's very empowering, and certainly not one that's creative or exciting. Often, machine learning is something that is done to their data, and they don't particularly benefit from it. So I'm interested in how we can think about other experiences with data and how we can make people's experiences less disempowering, how we could use tools like these to help people understand what machine learning is doing and hopefully encourage them to have a voice in shaping how machine learning is used. So with that, that concludes my presentation. Thank you very much for listening, and I'm happy to take questions if we have time.
Thank you very much. I mean, people can turn on their mics and ask questions if they have any.
Yes, I have a question.
Hi.
Hi, Rebecca. Thank you very much for your presentation. I really love the way you demonstrated how can machine learning accelerate the process of creating prototype, etc. I'm also working on a way to compress deep neural models in order to implement them on hardware.
Great.
Can you just give some advice to like you talked about transfer learning, you talked about downsampling the image, and you also talk about some aspect to compress model, and I was really impressed by your Wekinator, how it can learn very fast. So do you have some ideas?
Yeah, so I'll tell you a couple things. So this always makes people very surprised, I think. The algorithm that I used in the first demo, which was super, super, super fast and pretty darn accurate for image recognition from that downsampled image, that was a one nearest neighbor classifier.
Okay.
So, and, you know, I think people often discount these really, you know, old, rickety, unprincipled methods, but actually, you know, they work really well when you have features that are not too horrible and when you have people able to give very targeted examples, right? So I'm not actually trying to generalize that much. I actually often making something that overfits works pretty well because I have this ability to iteratively change the data set. So we could go into the mathematics of why that is, but I think, you know, when it comes to the kinds of stuff that you asked about and the kinds of stuff you're working on, a few observations to share. So first of all, you know, obviously transfer learning often gives us those kinds of features, right? So if you plug in MobileNet or something as the front end to that rather than that downsampled image, you can do a lot, and you can, you know, use a one nearest neighbor with like, you know, 5 examples and often get like amazing performance. So I would say that's an application of, you know, existing models that can be really fun and can be really useful and easy to understand for people if you wrap that up in an interface that they understand. But also, you know, the speed. I think I get really excited when people, by the work that people are doing to make these models more compact and faster in real time, because I think, you know, one of the real benefits to real-time work isn't just, oh, I can run something in real time in the world at a faster frame rate, or I can run it on a mobile device, but actually, you know, if you can make running, you know, building something Wekinator style perhaps with an existing model, if you can make it fast to train because you've got a good feature representation and good data, then actually that's really key to enabling this kind of iterative, exploratory, creative process. And, you know, having something that you can retrain or tweak within a matter of seconds, you know, up to maybe 30 seconds or a minute is just like it's a step change in how you create with something. So yeah, more
Yeah.
reasons to do the work that you're doing, I guess.
Okay, thank you so much.
Any other questions from the audience? If not, then I have one. So you've recently changed positions from Goldsmiths to University of the Arts.
Yeah.
How is that, or how has that, if that's not too recent, changed your practice and the way you're working with your students and the kinds of projects that you're now working on?
That's a good question. I think it's a little tricky to answer since I've really been working there a year, and that year has been completely insane with COVID and mostly just preparing video lectures and writing grants. So that said, I think, you know, I'm really excited about a few things in the context of the job move. First of all, you know, UAL is one of the best known art and design institutions in the world, and I get to work with students not just, you know, who are doing creative computing only, but students coming from around the university in our diploma program, which is for undergrads who might be studying sculpture or they might be studying graphic design. And I taught those students machine learning in the autumn, and they're just doing really cool stuff. But also we have a master's program for students who might be coming from any of those creative practices previously, and we're teaching them everything from, you know, Python programming to generative deep machine learning to natural language processing techniques. And that's, you know, it's exciting to think about, you know, as an educator, what are the sorts of skills that people coming from these rich creative practices need in order to become creative innovators as well as researchers, because some of them do want to become academics. As a researcher myself, I've become really excited in the overlaps with other domains. I just put in a grant proposal a couple months ago. We don't know the outcome yet, but it's broadly around the topic of decolonizing art and working with art collections and thinking about how do we enable people at museums, archivists, researchers from visual and fine arts to work more effectively with data in their collections. So it's not about necessarily creating new pieces of work, but how do we enable them to understand what data is there that might not have been attended to or surfaced by the kinds of practices that you've seen in British museums over the past 50 or 100 years, right? Certain people are getting ignored. Certain types of work might not, there's relationships between different works that's, nobody has paid attention to before. There's ways that language has changed in the ways that we describe artists or artworks. And, how do we unpack that and bring it to researchers' attention? How do we reorganize collections and present things in new ways to the public? And so there, that's a whole other field of thinking about how do we make machine learning and data more accessible to people who would really benefit from it, who have a lot of expertise in their own domains and don't want to become machine learning experts, but nevertheless, need to work with data more effectively. So that's another, hopefully, if that gets funded, that'll be a big multi-year project for us.
Thanks.
I had a small question. I saw in the examples of source of data you showed, you had an EEG headset.
Mm-hmm.
I wonder, did you try Wekinator with EEG and does it work?
Yeah, I've had a number of students do creative projects with NeuroSky, and I forget the other one that they've used. And the answer is sort of unsurprisingly, it depends. If you are, if you've got features that are relatively, an okay match to the kind of thing that you want to model, something analogous to that first demo I showed you with the downsampled camera. Like, it doesn't need to be great features, but you need to have like a reasonable chance of getting at the phenomenon that you're trying to model. In that case, yeah, you can build something pretty easily using that kind of interactive machine learning workflow. So certainly pieces where the performer wants to enter into a more meditative state or a more aroused state, and they're using that to manipulate the direction of some kind of sound or animation or game and so on. That's that's pretty easy to do with the sort of really standard features that you would extract from an EEG looking at different frequency bands. As soon as you want to do something much more complicated, right? You want to control a robot arm by thinking about your own body motion. I mean, the off-the-shelf sensors, obviously, that's a very tremendous, difficult data processing task where generally you want to have a really large data set. You want to have, probably some human thought that goes into how you engineer those features, or you want to be, ideally using, the state-of-the-art research methods to extract the features that you want there. So that, again, Wekinator is a good tool once you're at the stage of saying, I've got a relatively reasonable feature representation and I want to do interactive machine learning to build my own thing, my own interaction on top of this.
Okay, thank you.
Actually, going back to your question, Taze, if nobody has more at the moment, I do want to say, like, Creative Computing Institute is growing. We have undergraduate creative computing degrees, several master's degrees, including masters in data science and AI for creative industries, including masters in creative computing. We've got PhD positions. We also are hiring a bunch of folks, full-time and part-time academic staff right now, and we're going to be hiring a bunch more people later in the year. So we are definitely, send us your students, send us yourselves, and always looking around for collaborators on projects of mutual interest. So we're thinking in the next year or so about some of the Horizon Europe grants and so on, and who we want to work with there. So we're totally new. We've been around about 2 years now, and eager to interact with lots of new people.
Awesome. Maybe if there are no other questions, I have a very open one and not well defined, but so in relation with the work we do here at CSL, which is that we most closely work with artists from Sony Music. So one could say more mainstream or commercially, say, viable, that's a word, artists. In your presentation, you've mostly been showing amazing work with mostly experimental artists. Have you dwindled in the more commercial aspects of things?
Yeah, so I haven't done much in that space in music myself. I think the Interact-ML project is probably closest to that space, and that's with the gaming technology space. I've had some of my colleagues have used not just Wekinator, but related tools and some of our deep learning tools with probably most well-known would be Massive Attack and a London-based electronic artist named Actress.
Yes.
And I think, both of those projects were really, I think, successful, right? So in that the artists were happy with the kinds of tech that we ended up building for them at Goldsmiths, and now those colleagues are also with me at CCI. But also, I think it is a challenging space to be working in. The sort of time pressures that you have are different. The kinds of, really quality control end up being different. And of course, it's going to vary from artist to artist. And I think also, for better or worse, many people in those contexts, they are subject to the media pressure around like having a sort of story about how AI is used, which doesn't always map quite neatly onto what people find musically interesting as the creators themselves. So I think there are some really interesting challenges there. And I think that as a field, we are still relatively at the beginning of thinking about what is the tool set that makes sense. How generalizable can we make tools that, are maybe, going to be useful for a wide variety of artists, even across multiple popular music domains. And, obviously I know of a lot of the work that you guys have been doing there, and I'm glad to see you doing it. I wish there were more of it. But honestly, one of the things that I like about your work is you are thinking about artists. So much work in the computational creativity spaces is just sort of purely algorithmic. And I think when you think about how things are employed in practice, that's when the really interesting lessons get learned, and when the real opportunities get spotted, because it's not about the algorithms at the end of the day. It's about everything else usually.
Well, yeah, I think we agree on that. Awesome. Any questions left in the audience? If not, then maybe we should call it a day. It's been a long one and a very interesting one. Thank you again for your talk and the questions you answered. It was fantastic.
Thank you so much for having me.
And see you.
See you. Have a great day there.
Bye-bye.
Bye.
Bye.
Thanks a lot. Thank you.
Bye. Thank you.
Bye.